Good evening, Shril.
Hey, ma'am.
How are you?
I'm fine, ma'am.
Merry Christmas.
Merry Christmas, ma'am.
Okay, so today, Shril, I want to ask you, in maths, I just don't know like how many chapters are left. Can you just tell me like names of the chapters so that I can see how to move on with syllabus? Like,
We have two more chapters left. Wait, we have two more chapters left.
which one? The circle we are doing and statistics and probability. These two.
We have that surface area and volume. Wait.
Surface area we did now. Like before circles, we just
Sorry,
completed.
sorry, no, I got confused. Never mind. No, we had statistics and no, never mind. It's just one chapter because probability and statistics is one chapter.
Okay, okay. Only that chapter is left. Okay,
Ma'am,
and for revision, which chapters you want?
um, I think mainly the geometry chapters.
Okay, that lines and angles, triangles, and like all geometry, like quadrilaterals and right?
Yes,
These.
ma'am.
Okay. So in science, if I'm not wrong, like we are done with almost like all chapters, or like second chapter in chemistry, fourth chapter in chemistry, and work energy power in physics, and force laws and motion for revision. Right? We are left with these chapters, right?
Right, ma'am.
Chapter 2 for revision and chapter 4 we need to do in chemistry, right?
Yes, ma'am.
Okay, so today let's do science because alternate days, we should keep alternate days. Last Sunday we did maths and Saturday science. So today let's do science because alternate days are better. Okay.
Okay, ma'am.
So just tell me like out of these four chapters in science, chapter 2 revision, chapter 4 in chemistry, force laws and motion and work energy power. Like which chapter you want to do?
Oh, could you repeat, ma'am?
Chapter 2 that is matter around a sphere, and chapter 4 that is structure of atom, and force laws and motion that is for revision, and work energy power. Like these four chapters are left, right? So today you want to do which chapter?
Um, let's start chemistry.
Okay, chemistry, which chapter? Like 2 or 4?
Four.
4. Okay, let's start with new chapter that is structure of atom, right?
Right.
Okay, let me share my screen. Just 1 second. Is my screen visible?
Yes, ma'am.
Okay, Vijay. So today we are going to start with chapter 4.
Four. Structure of the atom.
Okay, structure of
The atom.
atom. Okay, so Vijay, can you just tell me what do you mean by an atom? Like, can you define atom?
Um, an atom.
Yes.
An atom is the smallest. Like they're like the building blocks of all matter. They're
Yes.
smaller than anything we can imagine, and
Yes.
they
Yes.
can be
Yes.
divided into electrons, protons, and neutrons.
Oh, like when the atom was discovered firstly, na, we didn't know about the electrons, protons, and neutrons. In this chapter, like after like Dalton's theory, you have learned like Dalton's theory in chapter 3, right? Uh,
Right now.
so we are going to start with the Dalton's theory, and after that, we are going to start with chapter 4 because Dalton theory we need to remember. Okay, so atom is the smallest unit of every matter, right?
Yes, ma'am.
So, like, according to Dalton's, do you remember Dalton's theory, Dalton's atomic theory? Like,
What, ma'am?
you do you remember any point from the Dalton's atomic theory?
Um, in Dalton's atomic theory, we had there was ma- all matter is made of very tiny particles,
Yes, all matter is made up of,
really tiny particles
yes, made up of tiny particles called
called atoms.
atoms. Yes, called atoms, right? Any other point from the Dalton theory? Atoms are
Um,
indivisible. Atoms are indivisible in nature. Indivisible means in,
um,
indivisible means
as in they cannot be divided into smaller parts.
yes. According to Dalton, atoms are indivisible in nature, so that they cannot be divided into further parts. And basically, these 2 points are important in that. So, but do you know that atoms in atom there are three subatomic particles, that is proton, electron, and neutron. For that, like Dalton theory has been disapproved. Okay,
Okay.
right? But the see when the discovery of when the discovery of subatomic particles subatomic particles were done, means when like proton is discovered, when neutrons are discovered, when electrons are discovered, this Dalton atomic theory is disapproved, or like it is not approved, because according to Dalton, atom is the smallest particle, but inside the atom there are also subatomic particles that are, there are how many subatomic particles, which
Electrons, protons, neutrons.
yes, when this discovery of subatomic particles were done, Dalton's theory was disapproved. Dalton's theory was disapproved. Right. So there are three subatomic particles. Subatomic particles. First is electron. Second is proton. Third is neutron. What is the charge on electron, Bache? Like, is it negatively charged, is it positively charged, is it neutral? Electrons are,
Electrons are negatively charged.
yes, electrons are negatively
Charged.
charged particles. Protons, these are,
Positively charged.
yes, positively charged particles. And neutrons,
Neutrally charged.
yes, neutral. No, neutrally we are not going to say neutrally charged, because if it is neutral then there is no charge. Okay, it
Okay.
is neutral, that means there is no charge on it. Okay.
Okay.
So now we're going to start with the discovery of electron. How the discovery of electron took place. Do you know any? Do you know scientists who discovered the electron?
Um, the scientist who discovered the electron. I think I forgot the name.
Okay, I'll tell you. The existence of electron in an atom was shown or discovered by J.J. Thomson, right? Was shown or discovered by J.J.
Thompson.
Thomson. Do remember the year also for MCQ in 1897, right? So,
Right.
this electron discovery was done by the experiment called cathode ray experiment. Which experiment?
Category experiment.
Cathode ray experiment. Okay,
Okay.
that is cathode ray experiment. So, bache, what is this cathode ray experiment? So, in this, there is a cathode ray. It is a tube. This is a tube, and here there is a cathode, and here there is a anode, right? And here this is attached to a battery. But do you know like cathode is negatively charged or positively charged?
Um, Negatively or positively?
Yes, cathode. This is a cathode tube. Like you know, like in eighth class also you did a chapter that is chemical effect of electric current. In that cathode and anode was
Uh,
introduced. Uh,
yes, ma'am.
Cathode is negatively charged or positively charged?
Um, Cathode was negatively, right?
Yes. So cathode is a negatively charged electrode and anode is a positively charged electrode. So this is here, it is a vacuum pump. And in this tube, we have taken a gas at very low pressure. Okay. This is a battery. So what happens is when the Thomson just started his experiment, this is known as the cathode ray experiment. He has taken a gas at very low pressure inside this tube, and when electricity is passed, so from here this the rays carrying the small particles emerges. So see like this there are the rays from the cathode, they are going out of the cathode tube and they are carrying the small particles, and J.J. Thomson named these particles as electrons. They are negatively charged. Just this
Charged.
is an experiment. He has taken a tube, he has there is an anode, there is a cathode, he has attached this to a battery, there is a vacuum pump also, gas at low pressure. When electricity is passed from the cathode, there are the rays which carry the small stream of particles. He named that small stream of particles as electrons. Okay,
Okay.
so I'll write this, then you can note. Okay, I'll write this experiment. So this is Thomson passed electricity at high voltage through a through a gas at low pressure taken in tube. This tube is which is known as discharge tube. Which tube? Discharge tube.
Next.
And
Exhaust.
stream of particles were coming out of negatively charged electrode These are called cathode rays. And particles are negatively charged, and it was concluded. So how it is concluded, which is, see, there is a gas. Gas is also made up of atoms, small particles. So whenever a gas is taken and we pass the electricity, there are the like the rays from the cathode are emerging. They carry a particles with the negative charge, and then J.J. Thomson named it as electron. This is a simple experiment. Okay,
Okay.
it was concluded. They are okay. So have you drawn this figure?
Yes, ma'am.
Okay, so this J.J. Thomson, just write the name also of the scientist J.J. Thomson in 1897. And if you draw on this, just note down this. Once noted, just let me know. Okay.
Okay. Yeah, ma'am.
Okay. So now we are going to note down the some of the characteristics of electrons, like what is the charge on electron, what is the mass of electron. Okay. So the topic is characteristics of electrons. So first is the mass of an electron. Mass of an electron is equals to 9 into 10 raised to power minus 31 kg. Charge on electron is equals to 1.6 into 10 raised to power minus 19 coulomb. Coulomb is a unit of charge. Okay,
Okay.
this is a negative charge, means this is right.
Right.
This is like mass of an one electron. This is the mass of one electron is 9 into 10 raised to power minus 31 kg, and charge on electron is minus 1.6 into 10 raised to power minus 19 coulomb. Okay. Next is discovery of proton. Discovery of proton is similar to that of electron. In the proton was discovered by Goldstein. Okay, the
Gold.
same
Okay.
Goldstein. The same experiment was done by the Goldstein. In this, in the case of electrons, the rays are coming from the cathode, and they named as a cathode rays, and the particles in the cathode rays as an electron. In the same way, Goldstein has passed the electricity from a gas at a very low pressure, and the rays coming from the anode that carries a very heavy particles, that he named as a proton. The same experiment, but only the difference is the rays from the anode. Okay,
Okay.
so here, right, when Goldstein passed electricity at very high voltage through a gas at low pressure taken in the tube, stream of heavy particles coming from anode, that is positive electrode. These rays are called anode rays because they are coming from anode. Okay, anode rays. A second name is all canal rays also.
Canal rails. Okay.
And these particles are called protons. These positive particles are called protons. This is the same experiment done by the different scientist, and in this case, he has taken the positive electrode and he just named that particles coming out from positive electrode as anode. Oh, sorry, protons.
Okay. One second, ma'am. Let me just note
Okay.
this.
After like one or two chapter, like we are left with this chapter and one more chapter, work energy power. Now after this, we'll do work energy power, and I'll bring one sample paper also. Okay, so we'll solve
Okay.
science.
Okay.
Okay. Done with it?
One second, ma'am. Done, ma'am.
Okay. So here the characteristics of protons. Characteristics of protons. So here the mass of proton is equals to 1.6 into 10 raised to power minus 27 kg. And charge is same. Charge of proton is equals to plus 1.6 into 10 raised to power minus 19. It's minus 19 would say. ठीक है. Okay. Coulomb.
Okay.
Okay, but see, electron is having the mass as 9.1 into 10 raised to power minus 31 kg. And whereas proton is having the mass 1.6 into 10 raised to power minus 27 kg, which is heavier.
Um, would it be the mass of proton?
Yes, proton is heavier because that is minus 31 and here it is minus 27, right? So minus 31 means they are more lesser, more into the lesser side. Then we have discovery of neutrons. There is no as such experiment like electrons and protons in the case of neutrons. It is only like neutrons was discovered by James Chadwick. Who has discovered? James Chadwick in 1932. And there is no charge. There is no charge on the neutrons. They are neutral. Mass of neutron is equals to 1.6 into 10 raised to power minus 27 kg. Same as that of mass of protons. Okay.
Okay.
So noted. I'll make one table. That table for like short notes. Okay. This is note. Have you noted, bache?
Uh, uh, yes, ma'am.
Okay. So just make one table. Just it is electron. Here is protons. Here it is neutrons. And who has discovered the electrons? J.J.
Thomson.
Thomson. Protons, Goldstein. And neutrons, James Chadwick. These are negatively charged particles. Negatively charged. These are positively charged. And these are neutral. Third is mass. Mass of this is 9.1 is into 10 raised to minus 31 kg. This mass. Its mass is 1.6 into 10 raised to power minus 27 kg. And its mass is same as 1.7 6 into 10 raised to minus 27 kg. Fourth is
Okay.
charge. Charge is 1.6 into 10 raised to minus 19 coulomb minus. And here it 1.6 into 10 raised to minus 19 coulomb in positive, and there is no charge. Just note down this 4 points so that everything of electron and protons and neutrons is in the one place. None बच्चे?
1 second, ma'am. One, two. Done, ma'am.
Okay. So the next, so before like at electrons were discovered and protons were discovered and neutrons were discovered, but nobody knew like how a atom should look like. So different scientists came and they just do the different experiments for the structure of atom. That is our name of chapter. Like how is the structure of atom? Where are the electrons put on? Where are the protons should put on? So there are different structures came out by different scientists. In this chapter, we have mainly three structures: J.J. Thomson structure of atom, second is Rutherford model of an atom, third is Bohr model of an atom. Now, Bohr model is more prevalent. J.J. Thomson model was also rejected. Then there were certain experiments. Rutherford model was also rejected. Then after that, at last, Bohr model came that is widely accepted by the chemistry. Okay, so starting with the structure of different models of atom, that is different models of an atom. So J.J. Thomson proposed first model of an atom in 1904, and he has this model is known as Thomson model of an atom or watermelon model and plum pudding model. Okay, which tell me like how a watermelon look like. The like, can you just tell me the structure of watermelon?
What, ma'am?
Can you just tell me the structure of watermelon?
It's like half. It's like a like half of a circle,
Yeah, half of circle.
semicircle.
Like, can you just tell me the colors, like how a watermelon look like? Wait, let me just take a picture of a watermelon from a Google. I'll explain you that.
Hello, ma'am.
Yes, yes, yes. Okay. I'm just taking one picture, then I'll explain you. My voice is coming now.
Yes, ma'am.
Okay. So, bache, according to J.J. Thomson, the electron model or the structure of atom looks like a watermelon. How watermelon? So, this is bache, this is a watermelon. This is a red part. And what is this black black? Can you just tell me? In the watermelon, what is this black black?
Seeds.
Yes. So these are seeds, and this is a red part which we eat. So according to Thomson model, atom is just like a watermelon. Means in this the red part, he has uh, he has taken the red part similar to the positive charge. In that, like a seeds, the electrons are embedded, right? So, like in there, positively charged material is whole atom, and negatively charged material are embedded in it, like the watermelon. Okay, like the seeds are embedded in the red part. So, in the same way, negatively charged particles that are electrons are embedded in the positive charge. Okay,
Okay.
so same way, plum pudding model. Have you seen the pudding? Like there is a kind of this thing, and there is like black thing on that pudding. So that black thing is the negatively charged particles,
Uh,
and the whole part that is whole, this the remaining brown part, that is positive charged. He has just corresponded the plum pudding and watermelon to the model of an atom. From his point of view, the atom looks like a watermelon and a pudding. Okay,
okay.
so write down like what he proposed is Thomson proposed that an atom consists of positively charged sphere and electrons are embedded in it. This is the first point. Second point was the negative and positive charge are equal in magnitude. Means this is equal according to him.
Okay.
So atom is whole. Whole atom as whole is neutral.
Okay, ma'am.
So this is like just mention also there's a watermelon as well as a plum pudding model also that this I have no, yes written. So this is the model of an atom is similar to watermelon and pudding, in which the that red part correspond to positive charge and black seeds correspond to negative charge, that the negative charge is embedded into the positive charge like a watermelon. Okay, just
Okay.
just note. All right, wait. Third is it looks like watermelon The red part corresponds to positive charge, and seeds as negative charge. Like seeds are embedded in the red part, likewise electrons are embedded in positive part. This one. You got to like how the according to Thomson like the atom should look like. According to Thomson, the atom is like an watermelon.
Watermelon.
Or just let me know after you know. Okay.
Okay, ma'am. Done, ma'am.
Oh, so further, na different scientists came and they just did the experiment on the atom, but this model was rejected further. And after this model was rejected, there was a new scientist who came named as Rutherford. Now he will give his model. Everybody is coming, everybody is proposing their own model according to their own experiments. And further, the new scientists are coming and they're just rejecting it. Okay.
Okay, ma'am.
So this was the first model, J.J. Thomson model. Now this the Rutherford has done some experiments and he just rejected this model. Now we are going to study about the Rutherford model, and it is very important. There is a very important, you have must have heard about that gold foil experiment, right? So this was under the Rutherford model. Okay.
Okay.
So just write this is next is Rutherford model of atom. So his full name is Ernest Rutherford. Ernest Rutherford was like was designed. Ernest Rutherford designed an experiment to see how electrons and protons are arranged in the atom. So this was an experiment named as gold foil experiment or alpha particle scattering experiment. What was the experiment named as? Experiment is gold foil experiment, and that is alpha particles scattering experiment. Okay, so this is the name of the experiment. So for this, what he did is he has taken a very thin gold foil, and that gold foil, okay, you know na, like every metal is made up of atoms. So for this experiment, he has taken a gold foil. Why, bache? Like, can you just think of reason why only gold foil? Gold is expensive also, but why only gold?
Um, it's because like gold is like it's easily malleable. Like it's like
Very nice, very nice. So gold he has selected because it is highly malleable. Malleable is, what do you mean by malleable?
malleable.
Yeah, like malleability, like this is a characteristic of metals,
Like it
right?
can be it can be like malled into thin sheets. Well,
Yes, they are drawn into
thin sheets.
thin sheets. So for this experiment, he has taken a gold because he wanted a very thin sheets. So for that, he has selected an metal that is gold. Gold is which is highly malleable. So next thing was alpha particles. Do you know about alpha particles? They are
Um,
having, yes, you know about alpha particles.
what one?
Alpha particles. Have you learned like what are alpha particles?
Um,
These are doubly charged, means there is a double charge. Doubly charge, that is plus two helium atoms. Alpha particles are no other particles. These are the helium ions. Sorry, ions. Doubly charged. They are charged helium ions. Just charged helium ions are known as alpha particles. Okay.
okay.
And since they have, what is the mass of helium? You know that?
Um,
4 AMU. Okay. The alpha particles are having high energy. They move very fast.
very fast.
Okay. Alpha particles, for this experiment he needed a one foil, that is gold foil. He has taken a gold because gold is highly malleable. It is easily drawn into sheets. Second thing he needed was alpha particles. Alpha particles are no other than helium ions that are having the double charge, that is of plus 2 charge, and they're having the mass of 4 AMU, and they are very fast moving particles. Okay, they are having the high energy. Okay, just note till here.
Okay. Um, Done, ma'am.
Okay. So now let's draw one thing. See, this is a fluorescent sheet. This is a screen. Okay. This is a screen. Here there is a gold foil, and from here their alpha particles are coming. So here from here the alpha particles are coming. They just strike the gold foil, and most of the particles, most of the rays goes the straight. This is the experiment result, and one of the ray got deflected like this, and one out of thousand ray come back. Okay, this was a three conclusion drawn from the experiment. So this is basically a gold foil. These are the alpha particles.
Mhm.
This is basically a screen. So this is basically a experiment. Now I'll draw this experiment like a, wait, like I'll draw now. Wait, this is like, let's assume this as a gold foil. Gold also have an atom, so I'm drawing the gold atoms. So what happens is these alpha particles rays are coming from here.
Okay.
So these alpha particle rays are coming. And what is observed was one of the ray out of thousand got deflected, and most of the rays goes the straight way. And one of the rays got deflected back. And but most of the rays goes the straight. Why does this
Okay.
happen? Just tell you, like, if most of the rays are going straight, from this what we can conclude, bache? See, if you are standing here and you're just passing the ball to that, and most of the time your ball is going straight, so what do you like observe? What do you conclude from that?
Um.
So if, see, if like you are, if I am here and you are just passing this ball to me, and it is coming in a straight path, what do you observe? Like, what do you conclude from this? Why it is going in a straight path?
Um. Because it's being thrown in at. Um. Not sure the reason.
Okay, I'll tell. This is go. See, if you are, see, if I'm standing here and I am passing a ball to you and it is going in a straight line, means there is no obstruction in between. If there is an obstruction in between, it will maybe deflect or it will maybe go in the different direction. But most of the time the ball is going in a straight path, means there is no obstruction, most of the places empty, right? Right. So this is what the Rutherford concluded, that if most of the rays are going in a straight path, means that most of the space inside the atom is empty. Okay.
Okay.
And if one of the rays just deflecting, means there is a huge mass here only in the center. After striking this huge mass, one of the rays getting deflected back. So that huge mass he has named as nucleus. Okay.
Okay.
So first we'll write the results of the gold for. First draw this, like, draw these two two, like these are separate. Okay, this is first and this is second. Just draw and just let me know. Then we'll write the results and then we'll write the conclusion.
Um, Ma'am, I didn't really understand
Okay, I'll tell you again. See,
during.
I'll draw again and I'll tell you again. See, this is one atom. This is second atom. This is third atom. This is fourth atom. See, just assume, bache, if I am passing this ray here, these are alpha particle rays. Okay, these are coming
Okay.
from the, these are alpha particle rays. After the experiment is done, what was observed, like most of the rays are going in a straight line path.
Straight line.
Only one or two rays are just deflecting back, and one ray, if it is coming here, and one ray is showing some small kind of deflection here, but most of the rays are going in a very straight path. So just imagine, if you and your brother or sister is playing a ball, catching ball, if you throw a ball here and if it goes in a very straight line, means there is no restriction in between,
Oh,
right? In the same way, if the alpha particle
right.
rays are going in a straight line path, means there is no restriction. The path is all empty, right? Right?
Right.
See, like, just link this to na, like if I am passing a ball to you and it is coming straight to you, means there is no obstruction in between. The space is empty. Likewise, in this, what happens is, if most of the rays are going in a straight line, means most of the space inside the atom is empty. There is no restriction, right?
Right.
And if one of the rays just deflecting back, see this ray is deflecting back, means there is some obstruction, some restriction. This restriction is called nucleus. Means there is a center
Nucleus.
having the huge mass. After alpha particle is striking this and it is deflecting back because of some restriction called nucleus. Okay. And on
Okay.
the other hand, almost all the rays are going straight because all of the atom space is empty. Okay, now
Okay.
you go. Now you got.
Yes, ma'am.
This is from the experiment. Now we'll write, then I'll explain you once more. Okay, So what happens is, right, the alpha particle scattering experiment results. First is most of the fast moving alpha particles passed straight through the gold foil. Second was sum of alpha particles are deflected by small angles. Most of the go straight line, but some are deflected at a small angles, like this. Okay, this is like deflected like this. Okay, 99% of the rays are going in a straight line, but one or two they are just deflected by small angles. Third is one out of
Angles.
one out of particles rebound. Rebound means coming back. Only see if there are say 12,000 particles. This is just an example. One out of that ray, one of that particle just rebound at one time only. There are 12,000 particles if, and one of the particles they just rebound means after striking the huge mass it just rebound like this. Okay, rebound means coming back.
Yeah.
Just these are the results, and now I'll write the conclusion. Just note down the results first, like what is observed from the experiment, what is happening in the experiment. These are results coming out of the experiment. So the observations of the Rutherford. Okay,
Okay.
let's note down the observations, then we'll see the results. Have you drawn this?
1 second, ma'am.
Okay.
Uh, one mom.
Okay. So now these are just observation. Now we will write to what are the conclusion he has drawn from this. So right, Rutherford concluded from alpha particle scattering experiment that, see, he has concluded like most of the space inside the atom is empty because most of alpha particle passed through gold coil in a straight line without any deflection. This was the first conclusion for the from the Rutherford experiment. That most of the space inside the atom is empty. Means in the most of the space there is nothing inside the atom. Second conclusion was very few particles were deflected from the path, indicating that positive charge. See, bache, helium is also positive, and if it is deflected, means there is a repulsion. So, means the nucleus is also positively charged, right? So, if one of the rays deflected, means there is a repulsion due to the positive repulsion, and one of the ray get deflected. Okay.
Okay.
So, very few particles were deflected from the path, indicating that positive charge of atom occupies small space. Third one is a very small fraction of particles rebound, indicating positive mass is concentrated at a very or in a very small space. Most of the particles just go in a straight line path because most of the atom is empty. Very few particles just deflected because there is a positive repulsion in between the alpha particles and the positive charge. And one of the particle rays this rebound because that mass, that nucleus is having or concentrated at very small space. Okay, because if, see,
Okay.
there is a nucleus here, and if rays are coming just strike, it will rebound. Okay, because nucleus is a kind of restriction, it won't allow the ray to pass ahead. Okay, this is small.
Okay.
From the Rutherford experiment only nucleus was discovered. Okay, so just write first and then we'll write about the nucleus. what is actually.